Igneous rocks are formed by the solidification of molten magma, either beneath the surface of the earth or above. There are two types, intrusive and extrusive. Intrusive igneous rocks are formed beneath the Earth's surface, and they cool very slowly, and they form many large crystals, such as this sample of granite. Now, the extrusive igneous rocks are formed as a byproduct of volcanic eruptions, and usually form very small, if none at all, crystals. For instance, this sample of obsidian, which has no crystals whatsoever. We're going to go into that later. Now, as far as compositions go, there's four main types for igneous rocks. There's felsic, intermediate, mafic, and ultramafic. Felsic rocks are mainly composed of feldspar and quartz, as well as silica, hence the name, felsic. Rocks with more than 65% silica in them are presumed to be felsic. Such as this sample of pumice. Now, the ultramafic rocks have, intermediate rocks are very similar to felsic rocks, but they only have a presence of 55 to 65% silica, which is still a lot. Mafic rocks have a 45 to 55% presence of silica, and they consist mainly magnesium and iron, hence the name mafic, magnesium ferric. Ultramafic rocks have less than 45% less silica. In most instances, the felsic mafic rocks are easy to distinguish from each other based on their color. So, hence the pumice, it's a felsic rock. It's really light in color, and it's also doesn't have very much heft. Versus, let's say, my basalt sample here, or gabbro, whereas they're both dark in color and a little bit more dense. Now, as far as the textures go, there's several. We have aphanitic, which is very small crystals. You would need a magnification to identify these crystals, kind of like that in this sample of basalt. Phaneritic, this is the complete opposite. These are crystals large enough to see with your naked eye, such as this granite. It's got great samples of quartz and hornblende, and I'm forgetting the other one right now. We have porphyritic. It's a variation between two different size crystals, such as in this sample of porphyry. It's got little bits of hornblende and quartz, and the gray background as well. There's glassy, which obviously it resembles glass. It's very smooth. There's no crystals at all. This is obsidian, which is actually very felsic. Vesicular, which is a porous rocks. They get these pores from escaping gas bubbles. They could also be described as frothy. This is pumice. And then lastly, there's pyroclastic, which is produced by the consolidation of fragments that include ash, bombs, tephra, from eruptions, such as in this sample of felsite that has little bits of hornblende among the tephra and the rest of the background. Now, moving on, we're going to go over sedimentary rocks. Sedimentary rocks are the product of sediment accumulating and cementing together. These rocks are composed of mineral or organic sediment. What happens is pre-existing rocks undergo chemical and mechanical weathering, either by tree roots moving them, acidic rainwater, gravity, wind, water, ice. There's a lot of things that can disrupt these rocks. These particles from the rocks are carried, from wind or water to a place more stagnant where they go to settle. This is going to happen in bodies of water, and from there on, this is where the process of becoming sedimentary rocks takes place. It usually takes many years. They're very soft in comparison to igneous rocks. Now, there are two main types of sedimentary rocks, chemical and clastic. We're going to go into chemical first. The chemical rocks are precipitated minerals or recrystallized shells with like an interlocking crystalline structure. Now, these are formed by the chemical precipitation from that concentrated solution in water. So when all these chemicals leach into the water, and they end up congregating in that pool of water where it's imagining it settles more, and then once this water evaporates, the chemicals are left over, and from there they precipitate, and it forms your sedimentary rock. So for instance, in this sample of travertine, He's got a fair bit on him. Now, the other type is clastic sedimentary rocks. These are some cemented and compacted clasts, usually from bigger rocks that got weathered away, and now they're cemented together. So, like for instance, in this sample of um, sandstone, much like its name implies, it's all sand that got cemented together, most likely from silica. And this sample, is very brittle. It doesn't take a whole lot of abuse. Now, another way that sedimentary rocks can form is actually from seashells and organisms, even like their fecal matter. And these bits of shells, in this fecal matter, they end up, they die and they congregate, eventually at the bottom of, the ocean, the lake, what have you. And they end up cementing together over time. The thing is, though, is these shells are mainly made of calcium carbonate. And because of this, if we do an acid test, it's really easy to distinguish these from the other ones. So here we're going to do a quick test. So hopefully you were able to hear and see that. Now, as far as the textures go, the grain size usually determines these, and they can go from large to small. So from large to small, so it'd be gravel, then sharp gravel, and then coarse gravel, and then we would have sand, and then silt, and then clay. This brings us to our last one, is metamorphic rocks. This is determined from the roots meta, meaning change, and morph, meaning form. These are formed from either previous igneous rocks, sedimentary rocks, or other metamorphic rocks that have been exposed to heat or pressure and underwent metamorphosis. These rocks are often referred to as the parent or protolith rock. The key factor to determine the composition of this rock, the metamorphosis, are time, temperature, and pressure. Metamorphic rocks formed through pressure are usually a byproduct of convergent plates and mountain building, as the pressure and the stress of these plates colliding and when subducting, pressure is subdued onto these rocks by the weight, of the new, the overlapping layer, or through the raw power of the stress as the rocks collide. This pressure rearranges the atoms into new compositions. Now, as for heat, there's a few ways as well. Usually, the introduction of a large mass of igneous material beneath the surface will end up heating the neighboring rocks and the metamorphic rocks, such as like if we had like gravel next to with the sandstone, now we have marble. Now, another source for heat would be the intrusion of a dike or sill, and this would like bake the nearby rocks into a contact metamorphic zone, kind of like the walls on a tunnel. As for metamorphic rocks, there's two texture types: foliated and non-foliated. Foliated has thin layers banded together. It looks like a stack of papers in a book, as we can see in this sample of shale right here. Now, there's two types of foliated: layered and non-layered. The layered has distinct alternating colors, such as we can see in this sample of mica schist. It goes light to dark and vice versa. And then we have the non-layered, in the slate, where it's just all in color. Now the textures are foliated layered, coarse grained, very fine grained, and foliated non-layered. Non-foliated crystals grow in several directions, such as this sample of marble, and they don't show any planes or stacking. Because of this, they don't show any alignment either. And they tend to be bigger in size, and they're more structurally stable, such as quartzite. I don't have a sample at the moment, but it's very tough. It's even tougher than quartz. These textures are determined by the size or the size of the grains of the crystals in them. It's usually either medium grained or coarse grained. That's all, and thank you.